Okay, so to continue with what we were doing at the end of the last video, so when you are gaining and losing electrons here and showing that with your compound, you have to continue adding atoms until you have the appropriate number of ions that will satisfy all of the valence shells. So we've continued that here. So aluminum, we left off. Aluminum now has 2 more electrons to give, the second aluminum we added. So we're going to add another sulfur. So some of these are going to get a little bit, might look a little bit messy to you, but it's because when you start doing this, you don't know how many you're going to need, right? So you just keep adding. As long as if I can see your valence electrons, your symbols, and your arrows, it's fine. Like the sulfurs don't all have to be in a row, or the aluminums have to be in a row. Okay, so then we're going to lose and go into the appropriate spot. So now we're in a situation where it's worked out. We have 2 aluminums, and both of them have lost the appropriate number. And then sulfur, we have 3 of them, and they've each gained 2 electrons. So now when we show the final compound here, we have to indicate how many we have of each. So I'll show you how to do that. So aluminum, we have 2 aluminums, okay, and each aluminum has a charge of +3. So the reason why that is, right, because it's lost 3 electrons. So you do not put +6. Okay, you're going to be tempted to want to do that. Each aluminum is a charge of +3. The number in front will let everyone know how many we have. So don't worry about changing the charge. The charge has to be for each individual ion. Okay, and then we have 3 sulfurs. So sulfur has all 8 valence that should be filled in here. Oh my goodness. That bothers me. Okay. And so for each sulfur, we have a -2 charge, right? So there you have it. So this is aluminum and sulfur. So what I want you to do is I'd like you to try out barium and nitrogen in the same way. You're going to show the formation and the final compound. So you're going to show me what's happening with the arrows, where the electron's going, and then the final ions with your charge and your brackets. So pause the video and give this a try. Okay, so I'll use a different color here just because we're working with something else. Okay, so barium, you should have noticed, is in group number 2. So barium has 2 valence electrons. Nitrogen is in group 15, which means it has 5. I'm trying to exaggerate, but it's not going. Oh, this is awful. Get out of here, nitrogen. Let's try that again. Yeah, I'm going to have to super exaggerate for some reason. Ah, that's so bad. Anyways, you get the point. There's 5. Okay, so barium is our metal. So we're going to show barium losing their electrons. Nitrogen still needs 1 more. So we're going to add in another barium. So barium is going to give nitrogen its last one. This barium still has 1 more to lose. So you know what? We need to add another nitrogen. Okay, that's better. Duh. And for that last one. Okay, so barium will lose. You should notice you need another barium. Okay, so there we go. And then it will work out right now. So we have 3 bariums. Each of them is +2. And we have 2 nitrogens. Each of them -3. Okay, so remember the metal is always first. So the positive charge, and you'll notice that actually with all the examples we did, the positive charges should be in the front. I should say not front, but written first. Okay, so that's actually going to lead us into the next part. So the next portion of this lesson is how do we write out the formulas for these compounds, and how do we write out the chemical names. Okay, so you're going to learn something called the crisscross rule. So let's recall, what do I mean when I say a formula? So when I say a formula, I mean when we're writing out the chemical symbols. If you remember when we did counting atoms, right? So let's say I had, right, Li3N. So we're going to go through, well, how do we know what numbers to write down? Because the symbols we kind of get, right? I'm hoping. If you have sodium and chlorine there as the symbols, you know that those are the atoms that you have in your compound. But what I'm going to go through is like, how do you know that this needs a 3 beside lithium? How do you know that it has no numbers? Okay, so we're learning what's called the crisscross rule. So we'll go through this. So these are the steps to get to your final final compound formula. But to be honest, once you get used to it, you don't really have to do this in the order that this is. You'll see what I mean in a second. So we're going to write the formula for a compound with calcium and iodine. Okay, so you always start by writing the chemical symbols. So we have calcium and we have iodine. Okay, so I'm going to do all 3 steps actually in one location. Okay, so we've written the formulas down. We're going to then write down the ionic charge for the ion as a superscript beside the element. So meaning we're going to write it on top. Okay, so let's talk about how do we get the ion charge. So luckily we have some helpers to help us. So on the back of your reference table that I've given to you, I should say your periodic table, there's 2 pages to it. So the first one is basically the general information with the symbol, the name, the atomic number, and the mass number. So this periodic table is actually specifically to help you to know the ion charge of elements. So you know how we did this work over here to see that it would be, let's say barium is +2 or nitrogen is -3. So this is a periodic table that will actually just, it's like a little shortcut. So it will tell you. So see how here barium is +2 and nitrogen is -3. Now on this periodic table, you're going to notice that it says, instead of -3, it says 3 negative. It's the same thing. So don't worry, the order of the symbol and the number doesn't matter. So please ignore this center part for now. We're going to learn about this in our next lesson. So just ignore this for a second. So on the periodic table, you're going to see that we have charges, right? So for example, lithium is +1. Chlorine is -1, aluminum is +3. Now, if you see elements that do not have charges, and actually I think these are the only ones here, but there's no charge numbers in the corner, that means that these elements do not form ionic compounds. So carbon will not make an ion. Boron will not make an ion, okay? So it just happens to be the type of element that is, okay? It tends to share electrons instead of transfer electrons. Okay, so let's go back to this. So we want the charge for calcium and the charge for iodine. So calcium is in group number 2, so it's a +2. Iodine is in group 17, which means it needs to gain 1 electron, so that is going to be -1. Oops. So it says +2, -1. Okay, now this is where the crisscross part comes in. So we're now going to crisscross the charges and write them as subscripts. So the -1 from iodine will actually crisscross down to become a subscript for calcium. And the calcium +2 is going to crisscross down and become a subscript for iodine. So what we really have is Ca -1, iodine +2, but I'm going to show you what to do. So first of all, you've never seen an element of chemical formula with pluses and negatives, right? So when you're writing out your crisscross value, you only write the numbers. Okay, you never write the plus and negative. Another correction. Remember when we did counting atoms, we never write in the number 1. By having the chemical symbol there, that automatically means the number 1. So when you're doing the proper formula, you actually never write in the plus and minus symbols, and you never write in the number 1. And this is our formula. So I made a little note down here just to remind you of exactly what I just said. So you never write in the charge symbols as part of the subscripts, and you never write in the number 1. Because by having this symbol there, by just writing Ca, that automatically means that there's 1 calcium. Okay, there's a few more rules to this, but that's essentially how the crisscross rule works. Okay, so we're going to do another example together, and then I'll have you try some out. Okay, so we're going to do an ionic compound that's formed with aluminum and sulfur. Okay, so again, I'm going to do everything in one spot. So we have aluminum and sulfur. We're writing the chemical symbols first. And then we're going to write down the charges. So let's go back to our periodic table. Aluminum is a +3. Sulfur is a -2. So aluminum +3, sulfur -2. So when we crisscross this down, the 2 will come down beside aluminum, the sulfur will come down beside, the 3 will come down beside sulfur. So remember, we don't write in the positive and negative symbols. So here our chemical formula is aluminum 2, sulfur 3. Okay, so remember, this is called the formula for that compound. So if you're asked to write out a chemical formula, this is what they're referring to, the symbols with the subscripts. Okay, so let's look at another one. So basically that was very straightforward. It didn't really change anything from the rules we had learned in the previous step. Okay, but now we're going to learn another rule. Okay, so we're going to do that on a compound with barium and oxygen. So again, I'm going to do everything in one step, like in one spot. So we have barium and oxygen. Okay, let's go back to our periodic table. So barium is +2, oxygen is -2. So +2 and -2. Okay, so let's crisscross them down. So this 2 will come down here, and the 2 from barium will come down beside oxygen. So now we have Ba2O2. Okay, but here's where our next rule comes in. If you are able to, you always want to have, you always want to have your subscripts as being the lowest possible set of numbers. Okay, so what I mean by that is, over here, 2 and 3 cannot be reduced down any further, right? What was the other one? 1 and 2 cannot be reduced down any further. However, because we have 2 and 2, we can actually reduce these down to being 1 and 1. So it's like we're dividing the subscripts to get the lowest common multiple, right? Yes, so then this would basically translate into 1 and 1. You always want the lowest set. So ionic compound subscripts must always be simplified if possible. It may not be possible, but if you can, you always want to reduce. Let's do another one like that. So let's say I had X3, Y3. Obviously, these are not real elements. I'm just kind of getting to the point of the subscripts. This would translate down to 1 and 1 because we can divide each by 3. If I had, let's say, 2 and 4, I can reduce these down by a factor of 2. So I can do 1 and 2. So if possible, you have to reduce. That's part of the rules. Now, if you can't, if it's X2, Y5 or something, I'm just making that up, you can't reduce that. So that would stay as is. It's only if you can.